Hello everyone, welcome back to the channel. In today's video, we are going to discussing about one of the most essential Kubernetes controller object, which is called daemonset. In this session is not only about what daemonset is, but mainly about why daemonset exists, when exactly we should use this daemonset, and how it behaves inside a real-time Kubernetes cluster. Okay, so the agenda for this video is first we will understand the real-time requirements that leads to the demand set, and then we will see why deployment fails in such scenarios. After that, we will understand what demand set actually does at the high level. Then we will go through the architecture flow of the daemon set, and we will see the real-time examples with the live demo. So where we will see that daemon set manifest file, which is YAML file, and we will go through the commands as well. Finally, we will summarize where the daemon set exactly fit among other Kubernetes objects. Okay. Before we start, let's understand the daemon set high level. A daemon set is a Kubernetes object that ensures every worker node in the Kubernetes cluster runs exactly one copy of a specific pod. You don't define replicas. Kubernetes automatically creates or deletes pods based on the node count. So basically, daemon set works at node level, not at the application scaling level. Now, with this high level clarity, let's move into the real time requirements because that is where Kubernetes concept always begins. Let's understand the real time requirements where the daemon set is pretty much is required. There are some application where the question is not whether the application is stateless or stateful application. However, the functionality of the application itself demands that the application must run on every server in the worker node, exactly one copy for the server or mission, not more or not less. Let me explain this slowly. Let's assume in your Kubernetes cluster has 4 servers. That means 4 worker nodes are there. You want to run one pod on each server. That means server 1 has one pod, server 2 has one pod, server 3 has one pod, and server 4 has one pod. So totally 4 pods, one on each server. Okay. So if tomorrow you have 10 servers, then you need 10 pods. If you have 20 server, then you need 20 pods. If you 100 servers, then you need 100 pods. So that means one server, then only one pod. So the number of pods is directly equal to the number of servers. That means number of worker nodes. Okay. Why deployment is not good fit here? Now think about the deployment. In deployment, what we discussed yesterday, you explicitly say replicas is equal to 3 or replicas is equal to 4 or 5 or 6 replicas you will give. Kubernetes creates that many parts. Okay, suppose say example, if you have given 3 replicas, Kubernetes create 3 parts. 4 replicas, 4 parts will be created. You can scale up or scale down manually based on your requirement. Okay, but here comes the important question is how many replicas should I give here? You cannot say create 3 replicas, create 5 replicas, create 10 replicas in the demand set. Why? Because the requirement is not about the replica count here. The requirement is one replica per one server. We have 10 servers, we need 10 replicas. That means only one replica for one server. Okay. So telling replica number does not make sense in this case. That's why deployment is not suitable here despite of being very powerful. Okay, so let's discuss what is the key requirement and what is the important here. So the key requirement is here you need to clear on I want one pod per one worker node. I don't want to manage replica numbers here. Then Kubernetes should automatically handle it. If a server is added, pod should be added. If the server is removed, the pod should be removed. This is the requirement is essential to understand the daemon set. So let's understand the daemon set. So this is where we will discuss about the core concept. So in Kubernetes, when we have this kind of requirement, we use a object called daemonset object, which is Kubernetes controlling object. So daemonset is a Kubernetes object that ensures one pod runs on each worker node, not on the master, only on worker nodes. You do not specify replicas. Daemonset decides replicas based on number of nodes. Now let's discuss about that architecture explanation. So how the architecture should be there and how we need to start. So let's understand the flow. First, you should have to write a daemonset manifest file. Then you need to apply it using the kubectl command line. Then the Kubernetes master creates a daemonset object. The daemonset then goes to the each worker node, creates one pod per one node, then runs the container inside that pod. So if we have three worker nodes here in this diagram, so the three pods will be created. One worker node, one pod. Second worker node, one pod. Third worker node, one pod. Total pods is three, total working nodes is three. Okay, so this is where Kubernetes automation really shines. Why do you even need this? Because in Kubernetes, anything you run must run as a pod. Even monitoring tools, even logging agents, even networking components, all those things you need to be run as a one pod. So let's take one example. If you take that monitoring applications, let's say I want to monitor every server in my cluster. I already have a monitoring application image. That monitoring application image must run on every node. So what is my requirement here? If I have 4 servers, 4 monitoring pods. If I have 10 servers, 10 monitoring pods I should have to run. This is exactly where daemonset is used. Then we'll see what daemonset automatically handles. So what and all things the daemonset will be automatically handles. Once you create a daemonset object, if a pod crashes, it recreates the pod on the same server by using the daemonset. That is the first thing the daemonset will be automatically handled. Then the next thing is, if a new server is added, it automatically creates a pod there. Then the third one is, if the server is removed, the pod is removed automatically. So you don't have to do anything manually. That is why the daemonset reduces the operational complexity during the technical hurdles. So this is where these all things the daemonset will be automatically handled. Then coming to the comparison, so where we discussed a couple of things in the previous class. So replica set. So using replica set, we can scale and replicate the parts. So whenever we need to be increased that scale, I want 10 parts, you can scale it. If the load is less, you can decrease it. You can specify the replicas, how many you want by using the replica set. When it comes to the deployment, in the previous class we discussed where we can do scale, replicate, rollout and rollback, mostly used for stateful applications actually, front end or application layers. When it comes to the current topic, which is daemon set, so one pod for worker node, no replicas defined here, which is the most examples here, monitoring, logging, networking, all those things we can do it by using daemon set. Then comes to the stateful set, use it for stateful applications like, SonarQube, databases like MySQL, PostgreSQL, Artifactory as well. Okay, so this is about the daemon set. So here I captured that the nodes actually. So what and all daemon set will do high level, just go through this. It will be very helpful actually. So the common use cases of daemon set, which we can use it for logging, monitoring and network plugins, security scanning as well. example I want to do for the scanning for one server, or if I have 10 servers in the cluster, you want to do for the security scanning, security assessment, like nessus scanning we need to do for the third party library scanning. So all those things you need to be install the agent per worker node, which is called one pod, then you can do it actually. Okay, so now let's understand the code base actually. So we need to explain the YAML file. So this is the code base which we are going to use now. So I will explain one by one. Now let's jump into the live session, which is a practical session. So there we are going to code line by line and we can explain the commands as well. So let's watch the code and we need to understand line by line what we defined here. Basically, your daemon set also part of the same API called apps/v1. That is the first line. The name of the object is we have given as a daemon set, which is called kind. Okay. And here I am not using the number of replicas, but I am just giving the selector. So the selector tells the daemon set manages all the parts which have given the label. So this is how daemon set understand which part belongs to it. Okay. The part template with the label and the same label what under the selector we have given. These labels must be exactly match the selector labels. Otherwise, daemon set will not link itself to those parts. Okay. We are creating one container using the Ubuntu latest image, and we define the image pull policy. If the image is not present, it should be pull it. So let's go to this startup command. So this is an infinite loop. It keeps the container running every 15 seconds. It prints the message. So this will help us to verify the logs. So that will be printed as a this is a daemon set object. Okay, so this is where we can clearly observe the daemon set behavior actually. So now let's execute this code. But before going to execute this code, now all it will do is how many servers there in our cluster now? Only one server, because in our Minikube we have only server. So what this code will do, it will create one replica. If you have two worker nodes, the daemon set will create the two replicas or two copies and then monitor. For that, it will use the label to check is that running on the same server or not. Okay. Now see, only we have one worker node. kubectl apply -f daemonset.yml. Now it is created. So kubectl get ds. So now here see, name we have given as a test daemon set, desired is equal to 1, current is equal to 1, and ready is equal to 1, up to date is equal to available, node selector, and it has created as 7 second. Your desired state 1, why? Because only one worker node we have. Current state is also 1 and it's also up and running. If we have two worker nodes, then the desired state will be 2. Okay. And now you can just say kubectl get parts. You can see it's running. That means we have only one worker node, then one pod is created and it's up and running. Then kubectl get parts -o void. You can see where exactly it is created. So this is the node IP. So here see, this is the node IP. Okay. Then kubectl get parts -show label. Now see, this is the labels we have given, and it has same label. Obviously, anytime if we delete the pod, what will happen? Let me delete this pod. kubectl delete pod. You can give the pod name. Then what will happen? It will recreate the pod on the same server. So now it's see again. See here, same label. Now it's created on the same server. If you want, you can see here. Okay, same server. So then you can run normal commands like if you want to see the logs, you can see kubectl logs -f. You can give the pod name. Okay. Now see it is printing the message for every 50 seconds. Now if you want to see that real-time behavior, so you can use -watch also. So that is a usual command. Here if you want -watch, if you can enter, right? So while creating time, it will give that real-time behavior, what it is going to do it. And then if you delete that daemon set, all daemon set parts will be removed automatically. kubectl get ds, you can give it, or daemon set also it will give. Okay, this will give, both are same, ds or daemon set. So kubectl get parts, then kubectl delete -f, then you can give daemonset.yml. Now if you can see here kubectl get parts, see it's terminating. kubectl get daemonset, see nothing is there. So it removed everything. Okay. So remember, if you want to run or deploy application which is used for networking, monitoring or logging, where you need one replica or one pod for one server, then the object you should be taking as daemonset. Okay. If the application is more of stateless, then you use the deployment. Then there is a one more type, that is where what if the application is stateful application, then we have another object called stateful set. Now before we go to that, there are a few more things we need to learn. We will come back a little later. Okay. So then coming to the final summary. So let's wrap up this session. So let's summarize this daemon set clearly here. So daemon set works at the node level. It ensures one pod for one worker node. It does not use the replicas, and it automatically recreate to the node add or node delete events. It is mainly used for monitoring purpose, logging, networking, and security agents. So basically, since every server is a part of the cluster, daemon set ensures every server always runs the required background services. This is where the daemon set removes the manual replicas pain points despite of cluster size. Okay. In the going forward, we will do couple of project. That time we will, with help of daemon set, we can set up the monitoring tools for the Prometheus Grafana, and we will do it. So before going to do that, so I was doing series of Kubernetes videos. Could you please go through each video? And it is very easy, it is very clear, you can learn one by one. Then while doing the project, it is very helpful actually. So thanks for watching. Could you please like, share, and subscribe?